Okay, I just backed up. This is part 3 of the week 4 lecture. I just wanted to give you that, back up a little bit and give you the other example that I was talking about. Let's say Randy scored 75 on a statistics exam. The class mean is 60 and the standard deviation is 10. All right, so let's compute the z-score and explain the result. Z, don't forget, equals x minus the mean divided by the standard deviation. So we take 75 minus 60 divided by 10. Okay, so 15 divided by 10 is going to be 1.5. And so the score of 75 is 1.5 standard deviations above the mean. Why above? Because the z-score is positive. Let's do this together, okay? And in a population, an average number of hours spent studying per week in a population of 10 students. All right, here's the distribution. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 12, 9, 11, 8, 10, 20, 12, 8, and 10. All right, so we're going to find the mean, the median, the mode, the sum of squares, the variance, the standard deviation, and the z-score for each of the raw data points. Got it? So the mean. Order your data points from the lowest to the highest value. There you go. You're with me? All right, now add the data and divide by the number of scores. Okay, so we add them all up and divide them by 10. And I miscounted before I said 11. They're 10. So it's 110 divided by 10 equals 11. The mean number of hours is 11. So the median is the middle value. Even number of scores. So the median is going to equal 10 plus 10 divided by 2. Okay, so there's 10 scores. And the median equals 10. There, right there. See it? The mode, the most frequent score, what was that? Tens. So the mode is 10. See, there's 3 of them here. Okay, let's do the sum of squared deviations. And so here's what we do. Here's the x scores. We take x minus the mean. What's the mean? 11. So we deduct 11 for each one of the scores, and we get negative 3, negative 3, negative 2, negative 1, negative 1, negative 1, 0, 1, 1, and 9. And then what's next? We square them babies up. So negative 3. Why do we square them? Because we get because we remove the signs. Okay, and so we square. Negative 3 times negative 3 equals 9. Negative 3 times negative 3 equals 9, etc. And then we add them up to get the sum of squares. So all these numbers equal 108. Variance, remember, this is a population. Okay, so the variance equals the sum of squares divided by n. If it was a sample, what would it be? N minus 1, that's right. So it's 108 divided by 10 equals 10.8. Standard deviation, remember, square root of the variance. So here we go. 10.8, square root of 10.8 is 3.29. All right, assuming that this population follows a normal distribution, we said that the mean equals 11. So 68% of the scores are expected, this is the empirical rule now, 68% of the scores are expected to fall within 1 standard deviation of the mean. So between 7.71 and 14.29 hours, 95% of the scores are expected to fall within 2 1.96 standard deviations of the mean. So between 4.42 and 17.58 hours, and this is 3 standard deviations out now, of all the scores, 99% of all the scores are expected to fall within 3 standard deviations of the mean. So between 1.13 and 20.87 hours. And here are the z-scores. Okay, remember how to do the z-scores? The mean is 11. The standard deviation is 3.29. There's the table. So let's go see how to do this in SPSS. All right, you can see that I have started the SPSS data editor, and I made a variable called zdata. And what I did was I typed in the 10 values that we had from our last problem. And if you recall, that problem was the one where we were doing the distribution with the 10 numbers. These were the numbers. I'll just move that out of the way. And here they are. So let's go ahead and do a z-score. So the first thing we're going to do is analyze, and then we're going to go to descriptive statistics, and then we're going to go to descriptives, and we're going to bring z-data, our variable, into the variables that we want to work with, and we're going to go to options, and we're going to ask for the mean, I'm not even going to ask for the minimum and the maximum. I'm going to ask for the variance, the standard deviation, and the kurtosis and the skewness, just because we were talking about those before. And we're going to ask for a we're going to order them by variable list. Okay, and we're going to say continue. And you see this neat little button right here, this little checkbox. Check that. It says save standardized values as variables. Hey, what's a standardized variable? Do you remember? Let's go ahead and see. Say OK. And you'll notice that it saved the z-scores for each number in the distribution. These are the z-scores. Pretty neat, huh? And here's the rest of the data. So we see that the n was 10, the mean was 11, standard deviation was 3.46, the variance was 12, the skewness was 2.25, and the kurtosis was 5.8. All right, but the most important thing that I wanted to show you here is that you now have the z-scores for each score in the distribution. Okay, that is the lecture for this week. If you have any questions, please go ahead and try this. Don't just watch it. Go ahead and go to the variable view, type in zdata, and you could even see that SPSS actually made a z-score variable, and it's called zdata, and put it in my variable list. So it is now stored. It has now stored the variable zdata. So there's the z-scores, and so if I wanted to work with the z-scores, they're there. And if you have any questions, please give me a yell. Thank you very much, and we will see you next week.